Hello everyone and welcome back to another video at Calculus Elementaries. This video is going to be pretty much a direct continuation of the last video, which was on the chain rule. So if you haven't watched that, you're going to need to know what we teach in that video, so go back and watch it. If you feel comfortable with the content of the last video, then let's move on to the next part of the syllabus. So first of all, I want to begin with giving you some standard derivatives. Now these are all given to you, so you don't need to worry about remembering them. They're in your formula booklet. But maybe it's just a bit useful to figuring out what all this notation is. So they've given you four functions here. We've got e to the x, which is a very, e to the x here, which is a very common function. This is the exponential function. And this is just a number. E is, if you don't know, E is a number. It's, I think, 2.718. It's a rational number raised to the power x. Next, we have the natural log of x, which is just a logarithm with base e to the power x. We have cosine of x, which is a trig function, and we have sine of x, which is another trig function. Then we have this kind of arrow sign, and this implies, I believe, I'm a little bit, because there's quite a few of these, there's a double arrow, there's three dots, but this sort of is, if f of x equals this, it implies that. And then here, this f prime, hopefully you should be aware of what these f primes are, and this is just the derivative of the function equals it. The first interesting thing is that the derivative of e to the x is e to the x, and that's just something you have to know. There's a way of proving it, but that goes way beyond the SR syllabus. The next thing is that the derivative of the natural logarithm is 1 over x. The derivative of cosine of x is negative sine of x, and the derivative of sine of x is cosine of x. Now these can be even I sometimes mess up and forget like the sign change, or I'm not really sure which one it is and which way it goes. So make sure to always in the exam check the sign and check that you're correct in using the derivative, because if it's wrong, that can mess up your answer completely. So these are just four you have to know. They're part of your syllabus. You just have to remember them. There's no sort of way of conceptualizing it as of now. So now that we've, again, they're never going to ask you differentiate cosine of x because that's already given to you. Although I'll never say differentiate e to the x because that's already given to you. So what they'll do is a question that I've put here, which is derivative of e to the x squared. Okay? So the first thing I want to think about is how can I transform this into something I know how to differentiate? And I'm going to say the trick is chain rule. So this one I'm just going to show you straight away. So we're going to use the normal chain rule where you go u equals something. And in this case, hopefully should be pretty obvious. You need to use u equals x squared. Okay? Because now this means that f of x equals e to the power u. And suddenly we know what the derivative of that is because we have that derivative up here. So we know, and I'm going to switch back to the other notation. I'm going to say, not f of x, I'm going to say y equals e to the u, because then I can say dy du equals e to the u. Okay, so we have u equals x squared, so that means du dx equals 2x. And simple chain rule, you multiply these two together, you get dy dx equals 2x times e to the u, and we know what u is, so we just plug that back in, 2x times e to the x squared. And that is our derivative here. So that was a pretty quick example, but I'm hoping you saw what I did there. I thought, okay, e to the x squared, I don't know how to differentiate. I can only differentiate when it's e to the x, or e to some singular variable. Okay, so then I do a substitution. Then I get y in terms of u. I differentiate. I get u in terms of x. I differentiate. I multiply the derivatives. And I get the final answer. There it is. If you're a little bit shaky on this process of du dx and dy du and all of that and multiplying it together, maybe go back and watch the other chain rule video, because that should clear it up. Okay, so that's very easily could give you, obviously it may not be something as easy as this, but it's exactly the same process. You just say u equals whatever's up here, and then you differentiate and multiply together. Okay, next one. Now we've got a cos function. I'm just going to tell you, I recommend to pause the video, think for about a minute or however long it takes you, what is the substitution going to be? So just do that, and then once you're back, I'll show you. So I'm hoping you had a try, and I think it is pretty obvious that this is just the substitution is u equals 3 to the x plus 7. Okay, this implies that I'm going to not use the f of x, I'm going to go y equals cos of u. And suddenly we can differentiate both this and this. This differentiates du dx equals 3, right? dy du equals, and this is when we go back and we double check if f of x equals cosine of x, then f prime of x, or the derivative, is negative sine of x. But instead of x, we have u. So this is just negative sine of u. Again, we do exactly the same thing, multiply together. Dy dx equals negative 3 sine of u, and u is this. So that's negative 3 sine of 3x plus 7. And that's our answer. That is equal to f prime of x. Or f dash of x, whichever one you prefer to call it. Okay, so that's a very easy question in terms of the amount of working and the understanding. This one may be a little bit more difficult. So we have the natural logarithm, and I might have to flip back just to remind you of what the derivative of the natural logarithm is. So again, now it should be getting pretty obvious that whatever's in the brackets of this function out here is going to be our substitution. So our substitution here is going to be x squared plus 1 over 3. Okay, that means that y equals ln of u, and I'll just flip back to remind you that the derivative of ln of x is 1 over x. But remember, this is not, we're now doing ln of u. So that means the derivative is going to be 1 over u. Okay? So that means 1 over u. Du dx. This might look a little scary because we have fractions and everything, but really we can just split this up into x squared over 3 plus 1 over 3. So that means the derivative of x squared over 3 is going to be 2 over 3x. Okay, I'm just going to write that down here. So this is x squared over 3 plus 1 over 3 multiplied by the power minus 1, 2 over 3x. That should be the answer. Okay, multiply them together. So that's going to be 2x over 3u. And then here u is x squared plus 1 over 3. So that's going to be 2x over 3 of x squared plus 1 over 3. Okay, so we're multiplying and dividing by 3, so those cancel. So that's just going to be equal to 2x over x squared plus 1. And that's done. So our f prime of x equals 2x over x squared plus 1. The nice thing about this is we've gotten rid of the natural logarithm. We now know our derivative is not in terms of a logarithm or e or a trig function. It's now simply in terms of x, which can be quite nice sometimes, especially when solving algebraically. And now let's do the last, or nearly the last question. So sine of root x plus 2 over 2. So once again, whatever's in the brackets, that's our substitution. U equals root of x plus 2 over 2. Y equals sine of u. dy du equals cos of u. Again, if you're not sure, always flip back, check, sine of x, cosine of x. There you go, done. Okay. Dy du is cos of u. Du dx, well, that's just going to be 1 over 2 square root x plus 2 times 1 over 2, which is 1 over 4 root x plus 2. If that isn't obvious to you, I would just think of this as x plus 2 to the power 1/2, and then a chain rule because we have the square root and we have another function x plus 2 in the inside. But hopefully by now you should be pretty confident with derivatives like this. So I may have made a mistake on camera, but I'm almost certain that this is the derivative. Again, multiply them together. So what we're going to get is cos of u over 4 square root x plus 2. We know what u is, it's just this, so we have cos of square root x plus 2 over 2 over 4 square root x plus 2, and that is our derivative. And that does seem quite messy. So yeah, sometimes these can get pretty messy, these derivatives. But I'm pretty sure that is also correct. Let me know if I made a mistake in the comments. Okay, now I'm gonna feel free to pause here. This is generally the level of difficulty that you'll be getting. Obviously more difficult in your exam because you'll get more and more confident throughout the year. But I'm going to try a more difficult question for those who are more ambitious. So feel free to stop the video there. That's all you need to know for now. I don't want to confuse anyone, but if you feel confident and you want to challenge, then feel free to try this last question. So what I'm going to do is I'm going to do a double chain rule using these special derivatives. So what I'm going to do, I'm going to take an actual logarithm, ln of cosine, sorry, no, I'm going to do ln of sine of x cubed plus 2x minus 3. Okay? Now this looks pretty scary to begin with, doesn't it? Actually, technically, sorry, these should be absolute around the argument of the logarithm. Okay, so first you might be thinking, oh my god, what the hell do I do here? So first of all, again, we're just going to take what's in these absolute, in the modulus. We're going to do that as a substitution. So I'm going to use u equals sine x cubed plus 2x minus 3. Okay, now we know y equals ln absolute value u. And I'm thinking, okay, well, this I know, you know? This is dy du equals 1 over u. I know that. What do I do here? I'm still confused. Can I not? You can't differentiate this. So this is what I mean by a double chain rule. Now we have to do another substitution. And I'm going to be really clear about how I do this. I'm going to move this u. I'm going to move this u here. U equals sine x cubed plus 2x minus 3. Next, I'm going to do another substitution. I'm going to say t, or whatever variable, whatever it is, t of x cubed plus 2x minus 3. Suddenly u equals sine of t. T equals 3x squared plus, sorry, dt dx equals 3x squared plus 2. Du dt equals derivative of sine of t is going to be cos of t. Okay, so now you might be thinking, okay, what do I do? I've got these three derivatives, they're all with different variables. I've got u, I've got t, I've got x. Okay, well, first of all, I want you to notice that if we multiply du dt by dt dx, we just get du dx. So du dx equals du dt times dt dx, which we know, which is cos of t, times by 3x squared plus 2. Okay. And we know that t is just this, so we know it's going to be cos of x cubed plus 2x minus 3 times by 3x squared plus 2. I have to go on to the next page here. Okay, so now we have du dx, we have dy du. Now what we need to do is multiply them together. So this hasn't worked out too nicely, but I'm just going to do it over here. So we have dy du equals 1 over u. Du dx equals this whole mess of 3x squared plus 2 times by cosine of x cubed plus 2x minus 3. And we have to remember that u equals sine of x cubed plus 2x minus 3. Now this, again, looks pretty scary, I'll grant that. We multiply them together, same exact process. Dy dx equals this top thing divided by u, right? Because it's 1 over u multiplied by that. So again, 3x squared plus 2. I'm going to omit the multiplication sign just to make it a little bit clearer. X cubed plus 2x minus 3. And we divide by u, remembering that u is this whole mess here. Sine of x cubed plus 2x minus 3. Okay? Now, this again is a bit of I believe this may be HR. No, this is not HR content. This is SL content for trigonometry, which I don't expect you to know right now. But if you do know, you know that cosine of something divided by sine of the same something is just going to be something called cot, which is 1 over tan. And actually, I just realized that is not SL content, but I'm going to put it in anyway, just to simplify it. And if any of you guys are interested, then feel free to look into what exactly it's a reciprocal trig function. So this is your final answer. And okay, yeah, this isn't on the syllabus, but this is just a taster of maybe a more difficult and challenging question where you actually have to go a bit beyond what's expected. and sort of think outside the box. But if this was really confusing to you, don't worry about it. It's not going to be on it. This is just an extra problem I wanted to include. So yeah, let me know if you guys have any problems in the comments, and I'll see you guys next video. Thank you for watching.